So first, let's talk about database. A database efficiently and centrally coordinates information for a group of files. So, what is a file? A file is a related group of records. So as you can see, here we have a customer file. Customer file has a group of records. Customer 1, customer 2, customer 3. Okay? And a record is a related group of fields. So for each customer, we're going to have multiple fields. For example, customer name, right? Their address, cities. So these are called fields. A field is a specific attribute of interest for the entity or the record. So if we have multiple files, we have database, but remember, they're coordinated efficiently and centrally. If they're not coordinated efficiently and centrally, and they may be a file approach. In a file approach, right, separate systems were created for each information needed. And each system had its own programs and files. This is a file approach, but it's not a database. A database reduces the inefficiency. Okay? A database's value comes from the consolidation of data into a pool. Okay? Into a pool that can serve a variety of users and data processing applications. That's why it's called efficiently and essentially coordinated. Right? Multiple choice. Right, data warehouse. Data warehouse is one or more very large databases containing detailed and summarized data for a number of years used for analysis rather than transaction processing. So transaction processing is for data use, but later on those data became old, and it's better to put them into a data warehouse. So analyzing large amount of data can serve as strategic purposes. This is referred to as data analytics. And in data analytics, one can find a vast array of sophisticated tools that allows for multidimensional analysis, complex calculations, data projections, and simulations. We're going to talk about those stuff in the next lecture. Right, and data mining now is become a hot topic, right? Data mining is using basically statistical analysis, right, to discover some relationship in the data. For example, data mining can use to find accounting errors, right? And data mining can use to find a previous unknown relationship, for example, in sales data. Right? For example, the credit card companies are using data analysis to find out fraudulent transactions. So advantages database. Right? It's integrated and easy to share and reduces redundancies. Right? And data is independent of the program that uses the data. So I can modify the program without touching the data, or I can modify the data without revising the program. And data is easily accessed for reporting and cross-functional analysis. Database system. So with the data, we also need a database management system, or DBMS. DBMS is a program that manages and controls the data and the interfaces between the data and the application programs that uses the data stored in the database. Okay, the database itself plus the DBMS and then the application programs. Together they are referred to as a database system. So let's talk about database system. So external users, they often have logical views of the data. For example, a sales manager views all customer information as being stored in one table. Right? This is a logical view. This is how people conceptually organize and understand the relationship among data items. At internal levels, okay, we can have this physical view of the data, which is how the data is actually physically stored in the system. Okay, and they could be very different. And DBMS software links the way data are physically stored with each user's logical view of the data. Database design schemas. To design database, you need to have a conceptual view of the entire database. Okay, the conceptual view, so we call these conceptual level schemas, illustrates different files and relationships between the files. We call these conceptual level schemas. And in this graph, this is a conceptual level schemas, right? How inventory data is related to sales data, and the sales data related to customer data. This is a conceptual level schema. And we also have the external level schema, is the user's view of the database. Right? The user's view of database is like this one. Either it could be a table, right? It could be a list. This is the user's view. And we also have internal level schemas. This is a low level view, which describes how data are stored in the stored and accessed. Right? This is the internal levels. Basically, we're going to give the details about the data storage, such as record layout, definitions, addresses, indexes. These is internal level schemas. Right? The data dictionary basically is a blueprint of the structures of the database and includes data elements, field types, programs that uses data elements, output, and so on. Alright, so we talk about the schemas. Multiple choice. DBMS languages. So a database management system is a program that manages and controls the data. Okay. We have several languages can use, right, to manage and control the data. We have data definition languages, which builds a data dictionaries, creates a database, describes the logical view of each user's, specify records and field securities constraints. For example, we can define the have access control of the data. That's DDL, data definition languages. Then we also have the data manipulation languages, DML, which is used to change the content in the database. For example, we can create, update, insert, or even delete data. That's a DML. We have the data query languages, which enables users to retrieve, sort, and display specific data from the database. And for accounting, probably we're going to use a lot of DQL, right? DQL, and part of the DML if we have access to the data. All right. Let's talk about relational database. So a DBMS is characterized by the logical data model or abstract representation of database contents, like conceptual view. So the relational data model, okay, which is widely used in DBMS, represents the conceptual and external schemas as if the data view were truly stored in tables. Okay, so what we see is a table, and it's not in one table actually. So we're talking about relational database. Relational database is a collection of two-dimensional tables, with each table representing an object about which we wish to collect and store information. Okay, together we have relational database, have multiple tables. And you can watch these videos to get a better understanding of what is relational database. Okay, this is our conceptual view examples. Okay, it shows customer sales information. We have customer name, sales invoice, invoice total. Right, this is a typical relational database, right? Two-way dimensional tables. And each row in this table we call a tuple, right? And each column contains data about attribute of the entities: customer name, sales invoice, invoice total. Looks like one table. But information, right, the data is really not stored actually in one table. The actual data is stored in a set of four related tables. Right, these are the four tables just to talk about. The conceptual view from the previous slide is taken from these four relational tables. If all of this information resided in one table, it would be a very large table with redundant data. So if we combine all four tables into one, we could do that, but we're going to create a super large table with a lot of redundant data, which is not inefficient, right? Inefficient. That's not the purpose of a database. But if we can separate them into relational data tables, then it becomes a much efficient way to handle data. As you can see, each table is related to one or other tables. Okay, so we're going to talk about that. Tables are related by keys. For example, for this sales, we have a primary key, which is sales invoice number. So a primary key is a database attribute or attributes that identifies each row in a table. Okay, so sales invoice 101 identifies this row, okay, in the table. Okay, and or other attributes will describe other fields in the attributes will describe the sales invoice 101. Okay, this is a primary key, and we may have multiple primary keys, and we call this concatenated keys. Sometimes we have two primary keys. Okay, we also have a foreign key, which is customer number right here. Customer numbers, foreign keys. Okay, foreign keys is a primary key in other tables. So obviously this customer number is the primary key for the customer tables. Okay, so these two tables are related through this, the customer foreign key in the sales table. Okay, because of this, two tables are related. Designing a relational database. So why we have a set of related table instead of one table, right? So I talk about the redundancies. So, but these are a more formal way to talk about the disadvantage to having just one large table. We have the following problems: update anomalies. Okay. So basically, if we put everything together and if we want to change just customer's address, for example, then we have to go through all the tables to revise. That piece of information can appear in many places, right? We have insert anomalies, right? If we want to add something, just a small piece of information, we have to add everywhere in the large tables. And also we have to delete anomalies. It occurs when deleting a row have unintended consequences, right? If we have a large table, but we don't have these problems when we have a set of related tables. We just revise one row in one of the table, and that's it. So let's talk about relational database design rules. So what are the rules we're going to follow? Okay, so each column in a row must be single valued. So for each column, for example, the salesperson, okay, we must have single value. For example, for invoice 101, I cannot have salesperson Jack Buck and Ass Knight together in just one place. No, we cannot do that. Okay, it has one single value. Then the primary key cannot be null. We must have a primary key. Okay, this is known as entity integrity. If a foreign key is not null, it must have a value that corresponds to the value of the primary key in another table. This is called referential integrities. Okay, so all the foreign keys, okay, must be, we can find a corresponding, must be a primary key in other tables, and must have values over there. For example, I list customer number 151, but if I couldn't find 151 in the customer tables, right, then we violate referential integrity. All other attributes in the table must describe characteristics of the object identified by the primary key. Right? So, for example, the primary key in this sales table is 101 for its invoice. All the rest of the information described invoice 101. Invoice date, right? Salesperson for that invoice, and customer for that invoice. Okay. If I list something that is not describing the invoice, for example, the customer birthday, or yeah, that's not good, right? That violates the design rules. Alright, so following these rules allows database to be normalized, solve a lot of those anomalies. So what is a normalized? We talk about normalized tables. Alright, so first we can see a big table. Okay, you can see a lot of information are redundant, and obviously that's not efficient. So we're going to talk about different forms of different normal forms, and how we're going to normalize table. Right. First normal form. First normal form. Okay, we're going to make all repeating groups must be eliminated by selecting a primary key. Okay, that makes each record or row different. Right? So in first normal form, we're going to remove these repeating groups. Right? Redundant repeating groups will be removed, and we're going to find a unique primary key for each record. Okay, once we do that, we're going to check the second normal form. So all the data are already in first normal form. There's no non-primary key attributes. Depends on only a portion of the primary key. So we call this partial dependency. Okay, only occurs when the primary key is concatenated. So when two keys are there, we allow partial dependencies. Otherwise, partial dependencies is not allowed. So if there are second normal form, we must break the table down into smaller ones. Alright, so from the beginning big tables, we first separate into two. We have the student record table. Now is out with student number, name, and their major. Okay, this looks great now, right? And we call this third normal form. So which means we can no longer break it. Okay, this table has been normalized. But what's left? We still have this course grade table with student number, course, right? Course description, instructor, right? Instructor office hours, locations, phone number, course grade, and it's still in the first normal form. Okay, we have a lot of repeating information. Like this, we have two student numbers right here, right? All right, so the course grade depends on both the student number and the course, right? Student number and the course. However, the course description does not depend on the student number, right? So we have these partial dependency problems. If you look at this record, the course grade depends on the student number. I want student number, student, and the course. So we have this grade. So the course description does not depend on the student number. It only depends on the course number. Okay, so we have a partial dependency on the student numbers. So we need to break it down. So we're going to have the third normal form. So assume they're already in the second normal form. So we're going to eliminate transitory dependency. Okay. Now we take the student grade out. Okay, this looks great now. Student grade depend on the student number and course number only. Now we have a concatenated these both are primary key, two primary keys. And we can no longer break it down. It's in the third normal form now. And we have the course instructor table. Okay? Although we removed a lot of repeat information, but it's still in the second normal form. Why? Where's the problem? Right, for example, I want to find Professor Ray's phone number. Okay? Professor Ray's instructor phone numbers. One needs to find the course he teaches. Right? Professor Ray phone number, course teachers. So why should I have the course he teaches? Right? right? If the course number is still the primary key, then the professor's phone number has nothing to do actually with the course number. We call these transitory dependencies. Instead, all the information right here, all the attributes right here, should only describe the primary key, which is course number, but the phone number has nothing to do with course number. Okay? So we're going to break this table down again. Okay? So we break the table down to a course table, which is only course number, description, and instructor, and then instructor tables with instructor as a primary key, office hour, locations, and phone number. So let's check the instructor table, right? All the attributes, office hour, location, and phone number describe the primary key. Okay, so all the four tables are normalized, right? And we are down. There's also semantic data modelings, which we're going to talk about in other lecture, lecture 10. Alright, so the last topic is data query. So one of the software we use is Microsoft Access. Microsoft Access is a database management system from Microsoft that combines Microsoft database engine with a graphical user's interface and software development tools, which is very powerful, but we only use a small portion of it, which is data query. Okay, of course we can build very simple data tables in Microsoft Access. That's going to be kind of easier. Okay, so we can try Microsoft Access from Microsoft 365. If you can download it and you have a 1 month trial, that should be enough for us. And by the way, if you have, I believe most employees will have subscription to Microsoft 365, then it will be free for you to use. And if not, you can have a try. And many times we're gonna find a student version for sale, which is if you can find a good deal, that will be great. But it's not necessary for you to learn data query. We're gonna talk about alternative way to learn and practice data query later. Okay, because for Apple Mac users, installing Microsoft Access is very difficult. Okay, you have to install like a mirror systems that mimics Windows and then install Microsoft Access. It's a lot of trouble. So we're going to talk about alternative way to do data querying if you're using Mac. So query. So what is query? Users may want specific information found in relational database. Okay, and not have to go through all the files. Just to use very simple languages to get what you want. This is a query. For example, an example of query might be, what is the invoices of customer ABC and who was the salesperson for those invoices? Right? This is from the textbook illustration. In Microsoft Access, okay, to create a query, we have two ways to create queries in Microsoft Access. We have a design view, which is easier for beginners. Designer views, okay. So to use designer views, we first need to know which tables we're going to use. Okay. For example, right, I'm going to find out what's invoice of customer ABC and who's a salesperson. I need invoice, I need customer information, okay, salesperson information, so these tables will be used, selected. And what are those specific attributes I want, right? I'm going to select sales, invoice, sales data, salesperson, and for customer ABC. Here, Lola, Dolly for a specific person. All right. So another way is SQL view in Microsoft Access, which is use the code directly to get what you want. Okay. All right. So in these YouTube videos, I went through both the design view and SQL views. I go through these two views, demonstrating how to build queries with textbook examples. Basically, the covers page 105 to 115. Okay, so, and also in these videos, I introduces a website called SQLite. So you can, if you are not using Microsoft Access, you can still practice SQL, okay, in that website, and also complete the assignment, okay, complete assignment.